Hello, my name is Robin at the Boonshoft Museum of Discovery. Today we're going to talk all about matter. So wherever you are, in your family room, in your kitchen, I'd like you to knock on a surface. That sounds pretty hard, doesn't it? All right, now I want you to find the adult in the space with you. Wave at that adult, smile at them, say you are awesome. Good job. I think you got some brownie points there. Everything you knocked on, everything you waved your hand through, and everything you looked at is made up of matter. Matter makes up everything. It really, really matters. Got that? So let's kind of think about this here. There are three main states of matter, at least three different types of matter that I think of when someone says matter. So I have a little game here, and this game is pretty fun. It's with balloons. I really like balloons. And the first one we have today is this lovely balloon here. Color, that's easy. It's blue, right? Can I squeeze the balloon? Nope, totally can't squeeze it. Can I shake it? I can shake it, but it doesn't really do anything. If I drop it, what will happen? Whoa. Could you hear that? That was really, really loud. So I'm going to sit here and kind of make a guess. What is inside of this balloon? Could be a rock. It could be ice. I just don't know. So let me think about matter here. When it drops, it's loud. I can't squeeze it. I can pick it up without changing its shape. Changing its shape. Solids keep their shape. You can't change their shape easily. In addition to that, I like to say you can pick up solids. So let's open it up and find out. So I've got some scissors here, and I'm opening it up. I'm not going to lie, my scissors are not the best. All right, and we have a big chunk of ice. Now, I bet some of you already guessed that. Well done, well done. So basically, we took a balloon, we filled it with water, and we put it in the freezer. That's a change in temperature. That change in temperature to really cold turned this into frozen solid water. Solids. They keep their shape, you can pick them up, and they don't change their shape easily. All right, now let's move on to the next balloon. Again, it's blue. Can I squeeze it? Oh, I can squeeze it. This is pretty cool. All right, if I shake it, it kind of goes slish, slash, slish, slash, slish, slash. Now if I drop it, what we'll do, and I'm going to drop it on my hand. Whoa. It doesn't really make a noise, and it kind of goes blob, blob. So what could be inside? Well, it can change shape. It takes the shape of whatever it's in, right? I'm guessing there's water inside, and water is a type of liquids. Liquids take the shape of the bottom of the container they're in, and they flow and they pour. So let's open it up and see what happens. I've got a lovely giant glass beaker here that I'm going to attempt to pour whatever is in here into. I might get a bit of a shower when I do this. All right, so it's flowing, it's pouring, it's going from the balloon shape to the beaker shape. This is awesome. We do indeed have a liquid inside of it. Again, taking the shape of the bottom of the container, and it flowed and poured. I like to also point out that liquids you cannot really pick up because they're flowing and pouring off your fingers. All right, we're going to set that one aside. 2 balloons down, 1 last balloon. This balloon is pink, and it's kind of sad. So this little soda bottle here, does it look like it has anything in it? It doesn't, but I think there is something inside of it. And I'm going to be able to know if I squeeze it and something happens to this balloon that is attached to it. So let's check it out. Oh, check it out. All right, so I definitely pushed something out of this bottle and it filled up the balloon, right? Pretty cool, right? So gas matter expands and fills up a space. So when I shove that gas out of here, squeeze the gas out into the balloon, now the gas has taken the shape of the balloon and filled up the balloon. This is pretty cool, right? So again, gas matter fills up the space it's in, and it really expands. Matter's pretty cool, and you can do a lot of fun things with it. So balloons, like I said, I love them, But I also love to do different types of experiments with different types of matter. So I've got Polyfoam A and B here and a little bit of blue food coloring. I'm going to stir it up in there. Now I'm going to take this other Polyfoam and I'm going to pour it in. Pour, pour, pour. I'm going to go ahead and scrape it a little bit. Sorry, I know you can't really see what's going on, but I promise there's not a lot to see yet. Now I'm going to stir it up really, really well. Add some of my own energy in there. All right, so immediately I've got a little bit of a color change. It's kind of got a green tint to it. Stir, 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 stir. All right, now I'm going to have the camera come close to it. And we're going to watch it. And we're going to see if anything happens. I know it's not the easiest to see, is it? But I promise it's worth the wait. All right, so check out this Polyfoam. This is crazy. So let me explain a little bit what happened. So we had those two liquids. Those two liquids came together. They had a chemical reaction, which is kind of like a big party between the chemicals. And lots of gas matter came about from it. This is really, really cool. So the gas, you remember, it expands. It fills up a space. So those gas bubbles started to expand. And as they expanded, and they kept expanding, it made it look like our liquids were growing. Really, really cool stuff here. Now, this stuff right now is super duper sticky. Once that reaction is all done, when there's no more chemicals to kind of have that party anymore, something extra cool happens. And this is where Polyfoam becomes really important to our lives. So this is a Polyfoam that was already developed a couple days ago. And check it out. It's solid. So we had two liquids, they made a gas, and when that reaction was over, now we have a solid. Now Polyfoam is a really, really common thing in your life, believe it or not. Maybe you got to go outside and ride your bike a little bit today. Believe it or not, that bike helmet has Polyfoam in it. Now if you have a car seat or a booster seat or a sibling that does, their car seat or your car seat, again, made out of Polyfoam. It's also what you're going to find in football helmets. It's there to keep you safe, especially your noggin. So pretty, pretty cool science here. Now we have one more experiment to show you based on matter. One of my favorite things to gobble up is a marshmallow. Love them. Now marshmallows are pretty much made out of sugar, right? That's why I love it. And it's got a lot of gas in it. That's why it's squishy. Now if I put a bunch of marshmallows inside of my vacuum chamber here, which is essentially just this big cylinder, it's got a tube attached to it, attached to this big giant machine off to the side. The vacuum chamber will suck out the gas matter inside of this, and something cool will happen. So I want you to kind of ponder, what's going to happen to those marshmallows if the gas gets pulled out? Gas likes to fill up, not gas. Matter likes to fill up a space, right? It makes up everything, so something's going to happen, right? All right, let's turn it on and find out. It's going to get a little loud. Okay, so this is pretty cool. The marshmallows expanded because that gas inside of them expanded. Does that mean I have bigger marshmallows to gobble up? No. It just means that they have, like I said, expanded. Gotten a little bit bigger, but not big enough to make a most delicious s'more in the world. Now, the pressure has also changed in here. And that means I can pick this whole unit up, which is pretty cool. If I let that gas back in, something even cooler will happen. Oh no, man, now my marshmallows are just little shriveled up, tiny, sad things. This would not make a good s'more. So that gas has essentially been sucked out of the marshmallow. Pretty cool, right? So we really like this vacuum pump here at the Boonshoft Museum of Discovery. So I'm going to do one more pretty cool science for you with using it. Shaving cream. I loved to play with it when I was a kid. My poor dad never had shaving cream because I used it all up. Don't do that at home without asking. All right, so got shaving cream inside of a beaker here. I'm going to put that beaker inside of my cylinder. I'm going to put the lid on. Pardon me as I duck down. I'm going to attach my tube back to it, and I'm going to turn it on. So keep a close eye on this beaker. Watch what happens. Take just a second. I want you to ponder what's going to happen to the shaving cream. Make a guess. Make a hypothesis. We know that with the marshmallows, the gas was pulled out of them and they shriveled up after they expanded. So there's a bit of a hint for you. All right, I hope you're done with that hypothesis, because here we go. This is pretty cool. Whoa, that's so cool. So the shaving cream, again, it expanded. Shaving cream is made up of like soapy bubbles, basically, and lots of gas, which is in the bubble, right? So again, that gas was pulled out, and as it was pulled out, the gas inside of the shaving cream, it expanded, and voila, we've got this cool giant white blob thing going on, right? All right, so again, we know that if we add that gas back in there, something crazy is gonna happen. I'm a little scared. This seems like it's gonna get really messy because it's shaving cream, but for you guys, let's see what happens. Oh, check it out. What a mess. Let me take this lid off. Ugh. Who's gonna come clean this? All right, gang, thank you so much for joining me in my matter conversation. If you really enjoyed this show, I'd like you to click that button. And if you'd like to watch more of our shows, please subscribe. All right, thank you. Have a great day.